in the lab doing some work. And as usual, brought to you by 3 Monkeys Solderless, home of the world's best cables for your pedal board. Got to check out our RCA cables too for all your hi-fi and car audio applications. So check those out. 3monkeysolderless.com. All right, so today I thought it'd be kind of fun since it's starting to get going now. I'm starting to build the Marshmellos, the 1 amps, which are the Van Halen 1 sort of solution amp that I've come up with. So today I thought it'd be cool to build a board, or to see how far we get in building a board and show you kind of how it's done. And this is basically going to be a standard super lead plexi sort of circuit, right? Because it's not too far off. The secrets in the ones are basically related to loading and transformers that I had designed and built for the application. So the circuit card here you're going to see is going to be very close or exactly the same as, like, a 1967 era super lead, all the way going through really the 70s. So let's start to begin. So I have the board here, which is like a phenolic turret board. All right, it's already pre-loaded with the turrets. Also has the nice little holes here for paying out your wire leads for strain relief to keep everything nice and functional. And what I like to do when I'm building amplifiers, so that I have consistency in my build from amp to amp as much as possible, and this is one of the things that I do to try to keep consistency through the builds, is to have a wiring jig. So I built this wiring jig specifically for the 1 amplifier, and it is here. And it basically, you load the board onto it and you wire, pay out leads or attach wires to the card and bring them out, and it tells you exactly where to cut the wires, so you have them at the same length from amp to amp to amp to amp. And wire length is, lead dress is critical in building amplifiers. So having them done all the same once you've worked it out is probably, the thing that you want to be doing. So I'm going to find, I should have had all my tools ready, but I'm a dingus. So let me get my tools here for building. You can listen to my laboratory noises in the background while I'm being a dingus here. All right, so let me find this will probably work. All right. I don't know what I did with my Phillips head. Anyway, so we have to attach the board to the jig. So we have some standoffs here. So I'm going to orientate the board, right, which would go this way, right? So we have it all set up. Take our screws, and yeah, this one's going to work. It's actually a really small head for computer work, but it was handy right by me, so I figured I'd grab it. All right, so there we have our board attached. So now we can start doing some leading. Now the first thing I like to do is to wire this stuff. Let me make room so I can make sure this is in frame. Okay, that's in frame. You know what, let's turn off the top lamp. I'm gonna see, if you haven't noticed, the picture quality should be a little bit better, because I built a, oh, that's nice. We're gonna try this. So we've got some ambiance. So I'm using my iPhone now for the lab work video. So I built a little jig to hold it above the board, off the work table. And this is what we're gonna go with instead of the Zoom camera, which I think is, it was good for all those years of doing things with. But I want to see, how much better the video quality can be. Take a hit of pink drink and continue on. So like I was saying, what I like to do is sort of wire the leads that are on top of the board, which would be related to the bias supply and then the high volt supply. And that makes things, in my mind, a little bit easier. So I'm going to be using some bus wire and some other sorts of things to kind of get the whole thing going. So that I'm going to start, let's go this way. Start by winding up for the bias supply over here. Right, so this is going to be a little lead, right like that. Trim off the excess. Excuse me. Get this little piece out of there. And I wrap them around the turrets, right? So it gets a good mechanical connection, right? Before we solder onto the metal. It's important. So that's sort of like one of the mil spec ways of wiring things, is to have mechanical connections, a 270 degree minimum wrap on the pole that you're going to, and then you're going to solder over that. So I'm going to continue with the B- supply, which is our bias supply. I'm going to use blue wire here, right? And I'm sort of wrapping it again around the turret, getting it nice and secured. There we go. And that's going to extend over to here. So what I'm going to do is I'm going to cut about this much off, and I'm going to mark a little pinch where I want the strip to begin. And again, with stripping, you got to be good at stripping. So that's really the reason why we invented the solderless cable system. It was for solder reasons too, right? That we figured a lot of people aren't very good with soldering, and that's fine, but not many people at all are good at wire stripping. So when you strip wire, you never want to touch the metal. You kind of want to pull it off, do a little bit of a shear of the jacket, and then pull it off. And you can usually tell if you've done it right if you look at your core, or if you look at the end that you cut. If you see a little bit of white on the insulation at the break point, you could tell that you broke that away, instead of cut it and then touched or possibly pinched the core underneath. So you want to look at the jacket to see that it has a little bit of a white hue to it, which means that was ripped as opposed to being cut. That's what plastic does. It kind of turns it whitish when you rip it like that. All right, so we have these points here ready. So I'm going to use my solder iron now, which is not turned on. So we're going to keep going, wait for it to heat up. And we'll do, let's do the negative feedback network next. So you can see right here is where the phase inverter is, right? And what we're going to do is we're going to take a lead, we're going to go around the other way. Actually, this way, right? So what we want to do is take this around, okay? And then we're going to bring it over to where the 100K feedback resistor is going to be, sort of like that, okay? Get it nice and tight. Give it a little trim on either side. Make sure it's tight against the post. And there you have it. Bend this up a tiny bit. There we go. Excellent. All right. Now, let's see if the soldering iron has gotten hot while we've been goofing around. And I like to use, for this, I'll use like a big chisel tip. A nice sized soldering tip on there. And the soldering iron set on it's basically its hottest setting, so I can get in and out fairly quickly without a lot of muss and fuss. So I kind of start on the opposite side from where the jacket is, so I don't melt the jacket, and then I apply the solder to the jacketed side, and then when it starts to melt, you know that everything's pretty hot all the way around. So you're not going to get a cold solder on one side of your turret. So you can see I'm applying it, getting a little solder on there to help kind of transfer that heat to the metal part. And here, I'm going to add a little bit of solder again. There we go. All right, so those are done. Now we could start on the B+, which is the high volt, right? And that's going to go and supply all of our plate sort of junctions, our high volt nodes with their power supplies. Oh, we got to do the presence network. All right. Negative feedback right there. Actually, I should wait on doing that one, which is fine. Let's see. You know what we're missing here? No, we're not missing anything. That's good. I thought I may have missed a hole, drilling out a hole. All right, so now we're gonna go from right here, which is the top junction. I know it's hard to sort of tell without the parts on the board, but when you do this long enough, you're gonna kind of see the parts even when they're not there anymore, you know? So there's that. And then we're gonna bring it over to here. So I'm just gonna lay this in. I'm gonna solder on this side. So really, I mean, the secret to this amp is not gonna be revealed in the videos. And in fact, you know, you probably couldn't necessarily tell at all what the secret is if you were to, you know, open up your Marshmello, the one amplifier, and look inside of it, because you're not really going to see anything that you wouldn't expect to see in a stock plexi, because it really is just a stock plexi that's mimicking, number one, a kind of a malfunction that I think was going on with his amplifier, as well as adding the effects of the Variac, which was definitely being used without having to use a Variac, right? So the amplifier itself, the transformers, the power transformers wound such that the net effect would be to apply, to modify the voltages, or to have the exact same voltages you would have across the B plus, the B minus, the filaments, all of the above, as it would appear, or as it would be, if you were to run the Variac to the amplifiers, or run the amp on a Variac that was set to about 85 volts, right around there. So that eliminates the need for to have a Variac on while you're doing it. And it also allows me to bias the amplifier exactly where I want it biased, and not rely on that if I were to build you an amp and you were to Variac it down, that you would have the Variac set at the right voltage. So I'm trying to make this as foolproof and as safe as possible. Okay, so over here we're gonna have the next point. Yeah, this bubbling noise is some YouTube mad scientist background noise. So I was hoping it was going to have a little bit more boings and maybe some crazy person laughing every so often, or some electrical noises like snaps and pops coming off something like a Jacob's ladder or something like that. But it's disappointing that it doesn't have that. So also, you're going to want to, before you solder, also do the board, or do the multiple connections, right? So here we're going to have leads that are going to go to a filter can that is located on the top of the chassis for the preamp. So we're going to get the lead out for these, right? So you're going to have one that's right here, and you're going to have another one that's right there. There we go. So I like to do these early so they don't get in the way, or I don't forget, rather, to do them. And you can see now here is where this is supposed to pay out to. So we're going to get that right to there. And we're going to do the other one here. Okay, and then there'll be a lead from here, which will be for the cathode follower's plate. So here's the next red lead right there. So let me get some blue here, because I like to do my plates in blue these days for the blue plate special. So this one's going to come up from here, and it's going to attach onto the same turret. On this one, actually, wait, we got to do it longer. I forgot. Because it's got to span 2 turrets. So we do one around like this way, right? Tuck it down, and then bring it around this way. There we go. Nice. Okay, so now I can apply some solder to this turret and get these all tinned in. There we go. Can get this one tinned in. And obviously, this is a lot easier to accomplish before you have your components on the board. So you're going to want to do this first, in my sort of methodology of building. All right, so now let's bring the blue and cut it to length. There we go. And now we'll continue down the B+ string, which would be from here, where there's a 10K, or will be a 10K. In my mind, it's there already. There we go. We can just go ahead and solder that down. There we go. And then it'll go to right here, which will be the node for the first preamp tubes plate supply. So I'm going to go ahead, cut it here, give myself a little pinch, and then I'm going to tear it away and then wrap it like so. I'm going to try to keep this video like an hour, like the other ones are, so I don't end up with an upload that takes 5 years. And I don't know how big this iPhone file is going to be. It's probably going to be enormous. So hopefully I'll remember to keep it at an hour. All right, so now where are we at? All right, so it looks like we have pretty much everything where we want it. And now we can go ahead and start to wire the rest of the circuit out. So I'll start with some ground leads. Let's start with those guys. So I'm just seeing something here. Yeah, there should be a hole right there. Ah, my drill is dead. All right, so we'll start moving. Doesn't have to charge for very long. So we'll come back to this when we drill it. So let's go over to let's go over to here. Let's start over here and we'll just go across the bottom. All right, so right here we're gonna have the feedback resistor. So I like to do those in gray. So I'm gonna grab me some gray. And that again is right here, right? And this one is going to be going over to the impedance selector. Oh wait, it's on the other side, so I got to kind of do it this way. I have it marked on this side because this side wasn't long enough. There we go. So you're going to see, I mean, building one of these amplifiers and doing it right and really taking your time and making sure that the thing is going to last forever without any problems, it takes some time and it takes a lot of patience. And, you know, it's going to be days of work, solid days of work to get this thing together. And then comes all the burning in and testing and tweaking. So it's a lot. It's a lot. So on the other side over here, I have the, let me move this out of the way. I have the point at which to cut this, and I can bring it around again. So now we're just going to kind of move down the board. Do some plates. Once again. So I always thought when you're doing things like this, when you start to want to say, oh, that's good enough, that is exactly the time when you want to stop and take a break. So as soon as you find yourself getting even the slightest bit sloppy, or you're like, oh, I think that one's good enough, you know you're either tired or aggravated or whatever, and you need a break. So that's sort of how I work. So, you know, when you get frustrated or you just have had enough for the day and you're getting kind of quick, you know you got to stop, because this stuff's too important to kind of just like half slipshot the build. Can't be done. Every one of these things has got to be like, it's like your child, right? You want to make sure that they don't run amok in society. You want to make sure that they're as reputable as you can get them. All right, we need some green. I mean, every once in a while you get a kid that just can't get right. And then you got to take a shovel. And you just gotta smash that thing. So I have, without question, I have had amplifiers where the thing, I was just unhappy with it. I was like, you know, occasionally you'll get something and it's like you've done everything right, you think everything's great, and for some reason the damn thing is not cooperating with you. And I will literally take the thing out in the back and beat it to death with a hammer and then chuck it in a dumpster, because I don't want anything to do with anything that's going to give people problems. So that's my story, and I'm sticking to it. Got a cathode here. I'm doing cathodes in yellow. In old yellow. All right, now we got more green. I should be listening to classical music. This bubbling is actually starting to drive me nuts. You know what? We're gonna put on some classical again. Thought it was a good idea, but this is just repetitive nonsense. of bubbling and gurgling. It's probably meant to go to sleep too. All right, so hold the fort. All right, so we're sort of fast forwarding a little bit down. I figured watching me, solder all these wires and bend them around might be a little bit boring, and it takes about an hour. So the whole video would have been just me twisting wires around posts and soldering. So we're going to continue with the board build and show you sort of how I like to do things there, and show you building of this Marshmello the one board, right? We're going to continue with that. So in sort of like the fashion that I've learned over the 30 plus years of building amplifiers and such is, methods that I've developed for developing consistency. So we talked earlier about lead dress and how this jig, helps with, assures that your leads are going to be the same length throughout each amplifier that you build, leading to consistent lead dress and, try to keep a consistent RF signature. The next thing would be the components that make up the amplifier, the resistors, the capacitors, and try to do your best job of knowing what the values of the parts should be, and then testing the parts that you're actually using to make sure that they fit into the range that you want for each component, right? So now I think a lot of people talk about like value drift and, mistakes and secret components. And, that's all well and fine. I've found it to be more helpful to test your parts to avoid being outside the range of normality and malfunctioning versus trying to decide whether you should have a 99.8K resistor here instead of a 100K resistor here, and going through a bag of 10%ers trying to find one that's within, basically 1/100% of what you want it to be there. I mean, stacked tolerances, which is a thing in engineering, which means that the accumulated error of components will add up, right? So if you have 3 components that are out by 5%, your stack tolerances will show you that you're going to have a larger variable of the final product when they interact with one another than just that 5%, that the window of swing changes. So I like to measure everything to make sure I know that what I've got is within reasonable expectations of what they should be, but more importantly also to make sure that the components that I'm using are tested and that they are what they are. Sometimes you're going to find something that's not quite right, and you're going to put it in your board without testing it, grabbing it in a bag, and you're going to find, something doesn't sound right or is wrong, and you're going to have a hard time tracing it down. And a little bit of preemptive sort of, action is worth a lot of debugging time for sure. So what I do usually is I'll take out my resistors and capacitors, and I'll start going through and using my meters and other testing devices that I use, which would be leakage, which would be the resistance, capacitive, leak down, all different things to see how all these parts are performing, and then sort them out for where they're going to go in the positions, and then lay them all out, right? So I'll sort of show you. I'm going to try not to spill it, because that would be also a bad thing, because resistors are roly-poly, right? So the more we move this thing, the worse it gets. But see, everything's rolling everywhere, so it's already unsorting. So these are the first batch of resistors that I'm going to be using in capacitors to load this board. So let me carefully walk away and put this down and not try to spill all the resistors on the floor, which will then negate all the time I've spent sort of ordering them, putting them in order. So now we're going to start wiring, or rather stuffing. Now each one of these leads would have to be, let's start over here on the high volt rectifier. So for that we're going to use some diodes, right? And I just built them all on the floor. That's okay. I sort of saw how a couple of them landed in a weird place, so it'll be fine. just a few fell out. So this is the magic of doing things on live and in a way that you're not used to doing, because you're having to do it in front of a camera and explain things. So normally I would have never moved my resistors from where they were, and I wouldn't have spilled a couple of them on the floor. So, all right, let's go for bending. Now for bending, I like to use this guy, which is, you know, a caliper, which I use for machining things. So I like machining parts and doing stuff like that too. So what I'll do is I'll just measure the space between these resistors on the inside diameter measuring side of the calipers. And then I could just bend them over this, right? And then over here, I'm just gonna clamp this sort of onto the table here with a C-clamp so that it stays in place while I stuff the board. So we just gotta do that. Okay, we're good. All right, so I'm gonna start taking the diodes and bending them to their desired size, or spacing rather, to fit the board. And I'll show you how all that goes. So now we've bent them, right? You can now snip them, and then you can put them in place. Obviously taking care to make sure you got them in the right way. And then this just keeps going on and on and on until your board is pretty much stuffed. You'll be soldering along the way at different times, strategically. And you're going to be stuffing the board strategically as well. So what I like to do is stuff the shorter leads, the shorter run leads, or the smaller lead spaced components first, because they're sort of on the inside and they're a little bit more difficult to get to if you've got the sort of like longer leads. So what I'm sort of getting at, right, is, let me just continue this, is that you want to try to always make things easy on yourself. Why make things more difficult? So wiring, stuffing, try to find ways of making things easier for yourself. Okay, so these are all in place now. So now we could just go ahead and sort of like, I'm gonna do what's called tacking them in a little bit first. So my soldering process for this is usually 2 stages. So I'll kind of get it tacked in. Like that. So the idea is to, you know, heat the part and then apply solder to the joint. So, you know, it's basically a lot like welding, right? Where you would have like your tool right here, your nozzle or whatever, or your stick, and you would feed your wire in from the side at the joint, and then you would sort of, you know, in case of like a TIG or whatever welder, you would kind of go and make your stack of dimes. So now we're gonna also go around it back one more time. I'm just gonna re-tin them out. Get in, get out. And now you can see those joints are glistening like silver, right? This one could use a little bit more. There we go. So now they look, you know, really nice, bright, shiny joints, just the way that I like them. So we could sort of continue on down the board here. And I'm gonna get some more of the parts out, right? Bend our leads, cut them to length, right, and place them in to where we want them. Now for cases like this where there's really only one, I'm just going to go ahead and use my pliers to do the bends. So I'll just kind of lay it in there where I want it. like so. That's a little faster than unclamping, setting, and reclamping the calipers. So it's about speed too, getting things done efficiently, right? So now we continue. Locating the resistor that I have so conveniently dropped on the floor. Okay. So what I'm wiring there is obviously the B- or bias supply. You know what, let's turn off the overhead light to get that kind of cool look. You know what, that's too hard for me to work. Looks good on camera, it doesn't look so good to my eyes. So I sort of need to be able to see, because this amplifier is going to be going to somebody, so I don't want it. I don't want to be building it in a compromised fashion where I can't see what I'm doing well. So if there's a little glare on there, I do apologize for that. So now I can go ahead and this is sort of what I meant by strategic building. So if I were, the next parts that would sort of go in there be this adjustable little doodad there, little adjustable potentiometer, and then these two capacitors, all right, electrolytics. And I'm sort of using my pliers to straighten the leads, as well as to remove any oxidation that would be on the leads, and it'll help with a good solder as well. So what I'm getting at is, if you place this in here right now, when you go to solder in there, you kind of got this capacitor in the way, and you might not burn it, but you might. So for me, it's like, now's the time to do sort of like a solder on these two. That's good. And then I'm going to go ahead and get this set up. So actually we have to connect a couple of the legs on this potentiometer to make it a variable resistor, like so, which it is anyway, but make it, you know, the way I like to have it function. So I'm going to join two of the legs together with some of my bus wire here. There we go. And we could go ahead and solder on it, and then we'll trim off the excess lead. Once we have that all soldered on. There we go. So we'll take off this little bit here. This and that. Okay. Then this guy can go here. All right, so it's a good time to solder this in. And some of you might be keen enough to maybe see the values of things here. Obviously, this bias supply is basically made or modified for the fact that this is being run on a lower voltage variac. and for how I want the amplifier itself to run, right? So in my case, I'm looking for a very particular bias point to get the amplifier to distort in a particular way. So really the whole sort of raison d'etre of the Marshmello is load lines and bias points to create an effect that I hear on those recordings that were released that were pretty close to being, especially the overhead mic tracks of Eruption, which I always like to talk about, being the most revealing of the tracks that I have heard of what Ed's amp sounded like in the room as it was, as opposed to after it received the special treatment I believe it had received from Don during the recording process and the mixing process. All right, so now also here we have another one of these capacitors. So we're gonna line that up. There we go. I don't think we're gonna go through doing this whole board watching every instance of every piece going in there, because again, that's gonna take quite an awful long amount of time. So maybe we'll go like another 15 minutes of building. There we go. So what I've done basically, modifying wise, is I've swapped out a couple of the, what you would call basically like range resistors that would give you the window of adjustability for the B minus, like how low or high can it go voltage wise, which is obviously variable and determined by this little trim pot here. So it has a limited range. So what you want to do is be able to set what that range would be by what's around it, right? So sort of the input resistor as well as the ground reference for the supply. All right, so now we have basically, you know, we have the high volt ready to go and we have our B minus ready to go. So now we can start adding in the dropping resistors, right? Which we have dropped on the floor because they're dropping resistors. So now let me see if I could find them in order again. Here's one, and here's the other. Good. So in yesterday's vid, or what am I saying yesterday's vid? In the vid of wiring out, paying out these leads off the board, towards around when I was on this side of the board, the channel that I'm listening to, which is, you know, just classical, random classical pieces, they had a piece that I think was it was a violin piece, Carmen, and I think the violinist was Itzhak Perlman. And holy moly, It's been a while since I've listened to that guy. Now, if you want to, oh my God, I'm just, his dexterity, and also, I mean, his speed is just ridiculous. Absolutely ridiculous. On top of that, there's also the fact that he played with this, like, this sense of humor, you know, where he'd throw in like a phrasing or the way that he sort of chose the notes or added something that would be playful in a way. Sort of like, look at this. It's almost comical, or not comical, but just, you know, playful humor. And, you know, I think there's some of that also in Ed's playing sometime. But I was thinking what it would be like if Perlman was decided to be a rock guitarist instead of, you know, maybe one of the greatest, or if not the greatest, you know, well, definitely in my lifetime, I think, the greatest violinist, if he had chosen an electric guitar and become a rock guitarist. You know, how crazy that would have been to listen to. That would have been pretty cool, I think. I mean, there have been a number, I have to get the rest of these. There have been a number of, you know, violinists who someone could say were, you know, just absolutely, you know, demons on the violin, could just, you know. But to, you know, and tastes vary. But for my money, I don't think that it could get any more interesting to listen to than him. It was something else, I'll tell you. It really was. Looking on the floor. So I'm looking for my 220K resistor. Must have bounced. Ah, here it is. I knew I was going to spill that on the floor. That's just the way my life works. I remember. Never mind. Never mind. I don't know what movie that was where someone like sneezed into the giant pile of cocaine on the desk that someone had. No, that's not correct. That's not a 220K. My eyes are failing. All right, I gotta find it. Aha! It flew across the floor. That is a 220K. The other one was a 22K. Or thereabouts. All right, here we go. Continuing on. Right now it would be time. Should we do, is that the same lead spacing? No, okay. You also got to do a little bit of strategic thinking about your lead bending as well. So like for here on the phase inverter, I like to bend it so that the body of the resistor stays low down, right? Because that allows for the surrounding resistors to sort of nest in there nicely, right? You can sort of see, right? So you're going to cheat these ones towards the top and that one to the bottom, and then you can kind of like, they kind of get nested together a little bit, so to speak, which I like. That's nice. Okay. And we'll just hand bend. Actually, is it the same lead spacing? Yeah, it is. So like I said, the resistor values that I chose are sort of in, you know, the circuit that I decided to work off of. You know, it was not quite the same lead spacing. Could be best described as a 68 through, you know, going all the way through what they did through the 70s, practically speaking. But some of the values that I found that may have drifted a tiny bit over the years in some of the amplifiers that I've owned. So there's that. All right, so let's keep going with, again, the shorter lead spacing. And then I think we'll, you know, kind of pause the video because I want to keep this around an hour. I don't want it to go on forever. And then we can keep moving on in the next video with more of the build. And just as a side note, I'm not going to give out schematics for the Marshmello. Some things you just got to keep. And I think giving out sort of like the Jose thing was a pretty good contribution. And the pedal, you know, a lot of the things that I've developed, the load boxes, I've given it away for people to build. But you can't do that for everything, because Teddy has to eat. You know? Yeah, so I'm all tangled up here with the soldering cord. All right, so I think this may be a good place to stop and let me concentrate on the rest of the build and get this board done. So when you see this again, it will be finished and we'll move on. All right, we've been working on it for about an hour, maybe a little less. Come this far. And we're just going to close it out. Got 2 more components to put on the board. So we're going to go ahead and do that. And then we'll, I don't know how much of this build to kind of go through, you know. So it feels like I need to get this stuff done. And filming while you're doing it all, you really end up taking a lot more time to do everything. Everything takes twice as long. But maybe we'll just do like some sort of like segmented sort of videos of the building. Like, here's the chassis. I'm going to put these transformers in the chassis. Here's the chassis with the transformers in it. That sort of thing. That might work better than, you know, just hours and hours and hours and hours and hours of building. Some people might enjoy that. I think I did that once before on that build for Vic Johnson, that Jose build. I think I might have done a full-on everything as it's done the whole way through kind of video. That really slowed it down. There. So that's done. So the other time that was a fake stop of a see you next time. This time it's for real. See you next time.